Hi all, and welcome to a new video of the Data Structures and Algorithms course. Today we will talk about strings. Not a standalone data structure per se, strings are considered to be a data type that behaves like a data structure. Nonetheless, they have a few characteristics that are worth mentioning. Before we continue, please take just a second to like the video, as it helps with the YouTube algorithm so that more people can benefit from this course. Also, please subscribe so that you will receive notifications when a new section of our course will be released. Now let's move on with understanding strings. A string is typically stored in memory as an array of integers where each character has been mapped to an integer. The way this has been done is through character encoding standards like, for example, ASCII. In ASCII, uppercase A has value 65, for example. You can read more about ASCII and other encoding standards on Wikipedia. For the time and space complexity, access takes constant time for both space and time, as it is stored as an array. Thus, of course, accessing elements is just the same as for arrays. Copying a string for both space and time takes O of n, because to copy a string you have to go through each character and copy it. And of course, because you copy it into a different space in memory, you allocate again O of n space. Traversing a string takes constant time for space, because we don't create anything else, and O of n for time, because once again we have to loop through each character of the string. For updating and in general altering a string, the discussion is more complex because we have to discuss about immutable strings. In some languages like C++, strings are mutable, but for the most popular languages like Python, Java, JavaScript, Go, etc., strings are immutable. This means that you can't alter them once you created them. If you want to alter a string, then a new one is created and the respective changes are made to it. We will see in the coding section of this video what are the consequences of this and how to improve performance when working with strings. Welcome to the coding section of our video. In this section, we will go over immutability and go a bit more in detail about it and explain why immutability is such an important discussion when it comes to strings. In Java, since the string is immutable, concatenation works by first allocating enough space for the new string, copy the contents from the old string and append to the new string. Therefore, the time complexity is O of n squared. If we look at the problem we have in front of us, if for an n equals 10,000 we keep appending hello to our string, we will see that this is a very slow operation. If we run it, we will see that it takes a lot of time, because every time we append, as I said, we need to allocate enough space and then copy the contents and then append. If you want your string to be mutable so that you can perform operations on it and alter it, there are some substitutions. One of them, and often recommended, is to split out the string into an actual array of characters and perform those operations there. Now, let's see an example for that. Let's say that our string is hello world, and in this case, as we said, we can split out our string into an array of characters. So I'm gonna say here to char array, and then I can modify this string, because it is mutable, in O of 1 time. I don't need to copy it into another string that will contain our alteration. So in this case, I'm gonna say string of 5 equals, and then I'm gonna add a comma. Now I can go ahead and print our string, and let's see how this will go. As you can see, a comma was appended after hello, and on top of that, we didn't have to create a new string. Thus, the time complexity is O of 1. The second solution to convert an immutable string into a mutable one, or to work with a mutable string, is to use built-in data structures or methods which are optimized for performance. So, since we are in Java, let's go ahead and have the same problem as we saw before, where n was 10,000 and we were looping over the string and appending hello. So in this case, I'm gonna take an int n of 10,000. I'm gonna take a string builder, and in this case, this is the data structure that helps me with my string, and I'm gonna say num string builder, and I'm gonna say for int I 0, I is less than n, string append hello. And I'm gonna have a string s, which is string dot to string. In this case, the operation takes only O of n, because string builder, it's not immutable. Thus, every time we append hello to the end of an already existing string. We don't need to copy it and create a new space in memory for it. So of course, if we run this, we see that it runs in very decent time. This is it for now. I hope this short video made strings more clear for you. In the next video, we will cover some algorithm problems related to strings, but for now, look over the theory, understand what strings are, and most important, understand how immutability impacts performance. You can already start working on some problems yourself. Otherwise, next week I will solve an algorithm problem here, and after that there are more on my GitHub repository that I will link below. I really hope that you enjoyed this section about strings from our algorithms and data structure course. If you did, or if you have any suggestions, please take a moment to leave a comment below. Don't forget to like the video, as it helps with the YouTube algorithm so that more people can benefit from this course. Also, please don't forget to subscribe and press the bell button to receive notifications when the next chapter of the course will be released. Thank you for watching, and I will see you in the next one.